Hello! So far we've used ChainRider to create a Hyperledger Fabric blockchain network and a chain code for saving temperature readings for our home IoT system. Then we have deployed the blockchain network, which is up and running. In this video we'll show you how to install and instantiate smart contracts. In Hyperledger, a smart contract is referred to as chain code, so we will use also this term from now on. Okay, so let's recap our sample blockchain IoT use case. We had a smart home system with temperature sensors collecting data from different rooms in the house. Every sensory reading blockchain record has a room temperature value and key attributes. If you are unfamiliar with this use case, please take a look at our tutorial about creating smart contracts first, before proceeding with this video. Okay, so let's start with the chain code deployment process. For a chain code to be accessible to peers on the blockchain network, it has to be installed to all peers who need to access the chain code. Let's say that the organization 1 and its channel O1 is going to be used to store our temp reading chain code. Thus, we need all the endorsing peers that are on channel O1 to have the contract installed. Moving on, through our REST API we can install a chain code in a few simple steps. So let's go to our Postman application. Find the Install Chain Code API. Enter the desired peers. In our case, those are all organization 1 peers. So we enter peer0.org1.chainrider.io and peer 1 as well as peer 2. Okay, just a sec for this. Okay, so next we enter the chain code's name, which is temp reading. Also make sure to copy the source code and the package.json files of your contract to the machine running the REST API, as we've done here. Great. Okay, so in the next one we will enter the chain code's path on the local file system of the machine where the REST API is running. As we've already copied the source code, for us this is our home folder and the temp reading. Chain code type is the programming language in our case, which is Node, and its version is 0, so that's fine. Once we are done with the API setup, we can send the request. This should finish quickly, and we have our confirmation message right there. Okay, so the next step is to instantiate a contract. After chain code is installed on the peers, a single blockchain peer instantiates the chain code on the channel. Let's move to instantiate chain code API in our Postman application, as we're right there. First, let's set up some things in the environment variable section. Specifically, we need to set the channel to which we're instantiating this chain code. We set O1 here. Going back to the request body, for peers we need to supply only one peer on the channel, so let's go with peer 0. Peer 0. Chain code name, version and type are the same as there was in the install API. Args is an empty array as there are no required arguments in the init function of the chain code. The policy refers to this chain code's transactions endorsement policy. Endorsement policies can be a topic for another tutorial, so we will not dig deep into them. Let's just say that this policy means that every invoked transaction on this chain code has to be endorsed by minimum one peer from organization 1. Now the request is complete and we can send it. This might take a while, so we're going to wait for a few seconds here. Great. Let's just check that the chain code container is running by running a docker ps command in our terminal. Yeah, it's right there. Perfect. Now we can proceed with interacting with the chain code. First, let's write something to the ledger. For that, we're going to use the invoke transaction API from our Postman collection. Let's just set up the chain code name in our environment variables to temp reading first. Right. In the request body, we need to supply a peer, so let's go with peer 0 again. But really, any peer that has a chain code installed can go here. The function we're going to call from the contract to perform the insert is insert asset, and we've defined our asset with 3 parameters, a key, a room and a value, so we enter them in this order under the arguments key. For our records key, let's say that sensor ID underscore timestamp is the key. The room is going to be the bedroom, and the temperature value is 19. And we can delete the rest of the sample arguments. Great. Let's fire up the request. Nice, that's done quickly. Similarly, you can invoke any other functions of the smart contract. The invoked transaction API has returned a transaction ID, so you could use that to query transactions by ID from our Postman collection in order to read all transaction info. Rather, we are going to query the ledger for this particular record directly with the Query Smart Contract API. This API's body contains again the peer, which will be peer 0. And we enter that under default peer in our environment variable. The function we're calling this time is called read. Read will query the ledger by record key. Thus, it accepts only one parameter in the args array, the key. If you remember, our key looked like this in the previous API. Let's just check. Under invoke transaction, copy that, yeah. Paste it right here and send request. And voila, we have our record. Great, that's it for today. Stay tuned because in our next video we're going to explore more complex querying possibilities with CouchDB. Don't forget to subscribe to this lore channel. See you soon.